Hello and welcome, friends. Welcome back to another session of Quant. I am Orko. So, what we do primarily here is we take quant topics that's relevant for CAT and non-CAT MBA entrance exams in India, primarily focusing on CAT. And like we take one topic, cover the basics and fundamentals in first session, and then do our two follow-up sessions of that topic. So first follow-up session will be on the foundational problems that will cement or strengthen your understanding of the basics that we covered in the first session. So the second session will be fundamental or level 1, level 2 kind of a problem. And the third session will be an advanced level session where we will talk about little complex problems or some level 3 problems. All of these problems are very much relevant from your CAT or non-CAT MBA entrance exam point of view. But today what we are going to do, we will talk about a topic, and this is the first session of that topic, is simple linear equation. I will say simple linear equation. Why linear? I will come there. But this is the topic for today, and we should cover the basics of simple linear equation. So that's what we are going to cover today. So without further ado, let's get started. So if you see what is simple linear equation and why it's relevant for that, so you see a lot of problem that can come which is equation based, and also there are certain problems which are stated in a sentence and that can be solved in terms of creating an equation and solving them. So from both that point of view, we need to focus on simple linear equation. And if we see last few years of CAT, there are a couple of questions in CAT which typically leverages this chapter. And when it comes to NMAT SNAP IFT, you can expect around 3 questions that is through this chapter. So from that point of view, it is very fundamental to understand, and there are certain quick wins in CAT. If you understand this concept, not very complex, but if you understand how we read a problem statement, form an equation and solve them, that's where it has most application. But also there are certain problems which are come purely based on equations. So we'll go there, we'll solve few of the problems in the subsequent sessions and some of them today also, and would like to see how we can leverage next half an hour or so in understanding the basics of simple linear equation. So to start with, we need to understand what is equation. So before that, let's say Orca as me, I have let's say I have 10 rupees more than Sham with me. So how you want to write this as an equation? So there is no way we have explicitly mentioned how much Orca has or how much Sham has. So what we have to do is we need to consider Sham. We'll say, let's say Sham has X rupees. X is a variable. It can take any value. X is a variable. So then Orca will have X plus 10 rupees. Okay. Now, can you think this is an equation? No, right? Because equation needs to have both left-hand side and right-hand side of an equation equal sign. So from here, we can't form an equation, or we can't say neither x nor x plus 10, neither x nor x plus 10 is an equation, because none of this has a something that is equated with. So unless something is equated with something, it's not an equation. So these are called as expressions. When you have only one sides, then these things are called expressions. When it comes to equation, let's say I say Orca has 10 rupees more than Sham, and let's say together they have 30 rupees. I'm just saying together they have 30 rupees. So then I know Sham plus Orca will be equal to 30 rupees. So I can say x plus x plus 10, which is with Sham is x, which is with Orca, that is x plus 10, is equal to 30. If I add this, it will become 2x plus 10 equal to 30. 2x becomes 20. 10 goes that side and become minus. and x becomes 10. So now I know Sham has 10 rupees. So basically I know Sham have 10 rupees and Arka will have 20 rupees. So that's when the equation comes into picture. So when there is a equal to sign, and then the left hand side will be equated to the right hand side, and then it forms an equation, or that's where we formed an equation from a statement. So if you see, this is a typical problem statement, and how you form this equation and then solve the problem statement, is that's how we are going to solve a lot of problem in subsequent sessions, or some of them in today's session as well. So this is the most foundational part of equation. Understand the difference between an expression and an equation. Now, if I tell you, previous problem you have seen, x plus 10 is equal to 30. Now if I tell you x square plus 4 is equal to, let's say, 20, how will you solve this? So you know x square is equal to 16 and x is equal to 4 or minus 4, right? So okay, 4 or minus 4. So here we have seen that x has two values, but here, if you remember last we have solved, x is equal to 10, so x has one value. So what is the difference between equation, this is equation 1 and equation 2? What is the difference between 1 and 2? The difference between 1 and 2 is, here x has single value, here x has two values. But why like this? Because the highest power of x in equation 2 is 2. Highest power here in this equation 1 is 1. So this is all 1, right? So this is called the degree of an equation. So what is the degree of an equation? Degree of an equation, nothing but the highest power of the variable in the equation. Highest power of the variable in the equation makes it a degree of that equation. So whatever be the degree of the equation will have that many solution. So what do I mean by that? So in this case, highest power is 1. In the first equation, highest power is 1. So x has one value. In this case, the highest power is 2. So x will have two values. Now that's the difference between an equation. So this is called, when there is one value, this is called as a linear equation, because here x will have one value. If x has two values, then these are called typically quadratic. We will have a separate session completely focus on the attributes of quadratic equation. So we will focus on linear equation today, where all the x will have one, the highest power of any variable in that equation will be 1. We will take a quadratic equation where we will talk about what will be the scenarios when the highest power of any equation is 2 and how we can solve them. There will be nuances to it. It's not always be straightforward as in this equation 2, but we will go and try to see what are the nuances later. But today we will primarily focus on x as a linear equation where the highest power of x is going to be 1. Okay, that's where it's called as a linear equation. Okay, so this is the foundational difference, and this is where we will focus today, is what is linear equation. Now let's say there is an equation 3x plus 4y equal to 12. Now here you see typically both the variable has the highest power as 1, here also 1, here also 1. So this is still a linear equation, but you see there are two variables. So if you understand, we will not be able to solve this equation and find out the value of x and y separately. If someone tells, okay, you know, x and y will take integer values, so then we can find out. So let's say if x is going to be 0, 3 into 0 plus 4y equal to 12. So 4y is going to be 12 and y is going to be 3. So when x is 0, y is 3. Similarly, we can say when x is 4, y is 0. And then we can say when x is 8, 3 into 8 plus 4y equal to 12. That makes 4y as minus 12. 12 minus 24 on that side. Y is minus 3. So y is minus 3. So that way, if say x and y are integer, you can still find out few values. But the problem is this is there is a lot of values possible, and we can keep continuing this. But also, if there are fraction solutions as well, non-integer solutions as well. So we will not be able to. So from here, it is not possible to have a unique solution for x and y. Now you might tell, okay, now since there is only one equation and you have two variables x and y, we are unable to solve. Okay, so is it always necessary to have two equations? So your answer should be, I need two equations for two variables. Okay, so let's say 3x plus 4y equal to 12. And let's say I'll give you another equation, 9x plus 12y is 36. So this is another equation. So this is equation 1. This is equation 2. Let's see if we can solve them. So 3x plus 4y equal to 12 and 9x plus 12y 36. Let's say this is equation 1, equation 2. Now, if you see, these are two different equations. If I multiply 1 with 3, I have to, then I will get 9x plus 12y equal to 36, which is nothing but same as the second equation. So basically your second equation is same as the first equation multiplied by 3. So these are, though it looks like two separate equations, but they are dependent equation. So when we say as dependent equation, when one equation can be derived by doing some operation on the another equation. So when one equation can be derived by doing certain operation on other equation. So what you need actually is independent equation. Independent equations is what you need to look for. So let's say I have 3x plus 4y equal to 12 and 5x plus, let's say, 8y is equal to 50. Then I will be able to solve them because those are independent equations. So there is no way you can do something on 3x plus 4y equal to 12 and get 5x plus 8y equal to 50. Let's see how to solve them. So if you have two equations, let's say 3x plus 4y equal to 12 plus 8y equal to 40. And let's say this is equation 1, this is equation 2. Whenever you have two equations and two variables, the best way to solve them is take any one variable from one equation and try to do something to make that equal to the same variable in the other equation. So what I said, let's say equation 1, I know 3 and 5 is there for x, 4 and 8 is there for y. So I know if I multiply first equation with 2, this 4y will become same as this 8y. Okay. So if I multiply 1 with 2, I will get, and you can't multiply only y section, you have to multiply the entire equation. So if I multiply 1 with 2, I'll get 6x plus 8y is 24. Let's say this is my equation 3. And I had my second equation, which is telling me 5x plus 8y equal to 40. So this is my equation 2. So my next job is to eliminate the variable which is same in both the places. So what I will do 2 minus 3, which makes me 5x plus 8y minus 6x plus 8y is 40 minus 24. So I will get 5x, 8y get cancelled. 5x minus 6x is 16, or I will get x is equal to minus 16. Right? And so I'll get the value of x. Now I will put the value of x in any one equation. Let's say in first equation I put x equal to minus 16, 3 into minus 16 plus 4 into 4y equal to 12. How will do that? Minus 48 plus 4y equal to 12, or we'll say 4y equal to 60. From here we can say y is equal to 15. So x is equal to 16, y is equal to 15. Right? So that's when we'll be able to solve it. Now let's see, we apply this in the second equation and whether it is getting solved. So 5 into minus 16 plus 8 into 15. Let's see how much. Minus 80 plus 120 is 40, which is satisfying the second equation. So whenever you solve a equation and get a value of x and y, try to put the value of x and y in the other equation which you have not used to get the value. So then you will see whether that equation is satisfying or not. So that will validate your solution. So that's the way. So the ideal way is take one variable, equate them with the value in the second equation, eliminate that variable by subtracting or somewhere adding based on the sign, and then get single variable and the constant number and get the other value of the other variable. Now put that value of the other variable in any one of the equation, we should be able to get the value of the second variable. So that's the way we should solve an equation. Now let's say in similar way there are three variables. Let's say I have x plus 2y plus 3z is equal to 15. Then I have 2x plus y plus 4z equal to 20. And then I have x plus 3y plus 5z is equal to 30. If I have these three, how should I go about it? Three variable, and I need three equation. You've got three equation. Okay. So for three variable, first take two equations. So I'll say step one. Take two equation and eliminate one variable. So in this case, let's say I take 1 and 2. I take 1 and 2, and I will multiply 1 with 2. So I will multiply 1 with 2 so that x becomes equal in both the places. That means I get 2x plus 4y plus 6z is equal to 30. Then this is my equation 3. So equation 3 and equation 2 both has 2x in common. So I can very well do 3 minus 2, and I will get 2x plus 4y plus 6z minus 2x plus y plus 4z is equal to 30 minus 20. So 2x gets cancelled. Y minus y, so that is 3y. 6z minus 2z. So 3y minus 2z, I get 10. So let's say this is my equation 4. Okay. Okay. So step 2, what we'll do, take other two equation. There is no 4 equations. So you take 1 and 2 first time, you take possibly 2 and 3 second time. Take other two equation and eliminate same variable. That means what we are doing, we now take 2 and 3 and we will eliminate x again. So let's say if I take 2 and 3 to eliminate x, I need to multiply 3 with 2. Okay. So if I multiply equation 3 with 2, what I'll get? Equation 3 is x plus 3y plus 5z equal to 30. 2x plus 3y 5z equal to 30. That means I get 2x plus 6y plus 10z is equal to 60. 15 to 2, 60. So let's say this is my equation 5. Okay, now my equation 5, and what is my equation 2? 2x plus y plus 4z equal to 20. So I'm taking 2 and 3. So equation 2 is 2x plus y plus 4z equal to 20. 2x plus y plus 4z is equal to 20. Okay. Now if I subtract, squares get cancelled. 5y plus 6z is equal to 40. This is my equation 6. So I have this equation, and if you see here, I have this equation 3y minus 2z equal to 10. So this equation and 3y z equal to 10, the equation 4. So basically what I got two equations with only two variables. So this one and this one. So now I have to do an operation in these two and possibly solve. So I know 2z, if I multiply with 3, it will become 6z. So can I do equation 6 plus equation 4 into 3? Since z has the opposite sign, I'm doing plus, so that they get eliminated. So 6 is 5y plus 6z plus 4, if I multiply with 3, so that becomes 9y minus 6z. So 40 plus 3 into 10 is 30. 30 plus 30. So 5y plus 9y becomes 14y. 14y is equal to 70. Y is equal to 70 by 14 or 5. So I know first I got y equal to 5. Okay. So y is equal to 5 is my first solution. Put it back in any one of this. So if I put it here, so 5 into 5 plus 6z is 40. So 6z become 15, and that means z become 15 by 6. So y is 5, z is 15 by 6. And if you put this value in any one of the given equation, you will get the value of x. So if you put it here, you will get the value of x from here. So that's how we do it. So whenever there are three variable, three equations, the simple idea is take any two equation, eliminate one variable, take another set of two equation and eliminate the same variable. You will get two equation with only two variable, and then you do the standard approach of two equation, two variable solution. That's the way we should solve a three equation, three variable kind of a problem. Now, let's say a lot of time you will only get two equation for three variable. Now, it is not always feasible to get the unique value of each solution. So let's say I will tell you x plus 2y plus 3z is equal to 10. Then I'll get 2x plus 4y plus 5z is equal to 30. Now if I get this, it only two equation but three variables. So there is no way you can get unique solution for all x, y, and z. There is no way you can get unique solution. But if I ask you, can you tell me what is the value of z? That may be possible. So when it is possible, remember, if you have two equations, and in both the equation, ratio of other two variables are same, then possible to get the value of third variable. So here I can see in the first equation x, second equation 2x. So that means x by 2x is 1:1:2. Similarly, 2y, 4y, the ratio is still 1:2. So there is a way we can find out what is the value of z. So again, let's say this is equation 1, this is equation 2. So if I just 1 into 2 minus 2, so that makes 2x plus 4y plus 6z minus 2x minus 4y minus 5z, 20 minus 30. Do that, 2x get cancelled, 4y 4y get cancelled, and the value of z as minus 10. So it is possible to find the value of an equation where the for a individual value when the ratio of the other two values are same. So that is a very important one you need to understand. Don't always think no question can be answered if there are only two equation, three variable. Depends on the question. We can still answer certain questions if there is a possibility of two equation, three variable kind of a scenario. But if they ask what is the value of x, y, and z, you can't do it. But if they ask what is the value of z only, you still can do it. So that's the whole ask. Okay. Also, let's say there are certain other scenarios. So let's say Arka went to a store and bought, let's say, 3 orange, 5 banana, 3 orange, 5 banana, 1 apple, or let's say 20 rupees. Now he went to another store in the next day and bought, let's say, 4 orange, 2 banana, and 6 apple at the price of 30 rupees. Now, can you tell me what is the price of 1 orange plus 1 banana plus 1 apple? So again, see, it is 2 equation, 3 variable I can understand, because let's say the orange prices are x, banana prices are y, and apple prices are z. So I can easily form an equation 3x plus 5y plus z is 20, 4x plus 2y plus 6z is 30. Again, 2 equation with 3 variable cannot be possible to find out the individual values of x, y, and z. But what they have asked what is the value of x plus y plus z. So in that case, if it is also possible, so if you see this 2 equation, if I just add these 2 equation, so then what I'll get 7x plus 7y plus 7z is 50. 7 into x plus y plus z is 50. That gives me the value of x plus y plus z is 50 by 7. So this is a possibility to get what is asked in the problem, may not be individual values of x, y, z. So there is a combination that can be answered. There is a single value that can be derived, even if there are only 2 equations for 3 variable. So be well aware of these things. There may be certain things which may be possible. There may be certain things which may not be possible. So be aware on those areas. So let's take another scenario. So let's write the problem. So let's say 3x minus 5y plus 7z equal to 12. X minus 3y plus 9z equal to 16. And let's say 9x plus 8y plus 31z is equal to 54. So if you have these 3 equations, can you solve this? So now you have 3 equations, 3 variable. Can you solve this? So let's do the same approach. That's what we were doing earlier. So let's say equation 1, I multiplied with 3. So what I'll get, I'll take equation 1 and 3 first, and try to eliminate x. So I will do 9x minus 15y plus 21z is 36. Now if I take from equation 1, and let's say this is equation 4, so 3 minus 4, what I'll get? So 9x plus 8y plus 31z minus 9x minus 15y plus 21z is 54 minus 36. So 9x minus gets cancelled. 8y plus, it becomes plus. So 23y plus 31 minus 21z. So 31 plus minus 21z, so become 10z is equal to 18. So this is my equation 5. So this is one equation with two variables, right? Similarly, if I just multiply, if I then take 1 and 2 and try to eliminate x, I will first multiply 2 with 3. So I will get 3x minus 9y, 3x minus 9y plus 27z is equal to 48, right? So now let's say this is equation 6. If I subtract 1 from equation 6, what I'll get? Let's do it. So I got equation 6. So let's do 6 from 1. So what is my 6? 6x, 3x minus 9y plus 2z. 3x minus 9y plus 2z. This minus, what is 1? 3x minus 5y plus 7z. So I get 3x minus 5y plus 7z. So 6 is 48 minus 12. So I get 48 minus 12. So 3x get cancelled, minus 9y plus 9y. So minus 4y. 2z minus 7z. So minus 5z. That is 36. So what we got? So we got 4y plus 5z is equal to minus 36. So this is my equation 7. Right? So we got that. So what is my, this equation? 23y plus 10z is 18. 23y plus 10z is equal to 18. Right? So if you see carefully, so then you can solve this two equation. But there is a certain time you will find out, if you are using these two equation, three equation and three variables, a lot of time you will see these two equation also become similar. So in that case, it is not possible to solve. A lot of data sufficiency question typically ask you to do this when they give you three equation, three variable, and you happily say it's all possible to find out x, y, z. But here it is possible, but there are certain scenarios when you see that after removing the same variable from taking a two set of equation and get two equation with only two variable, both of those two equations are similar or dependent in certain cases. If you recall the dependency that we stopped little earlier in this session, they will be dependent, or one equation is just derived from other equation. So that way it's not possible. So specifically when it comes to data sufficiency, or you have none of this as an option in the problem, go ahead and solve those three equation and see whether you are getting those individual values of x, y, z, and then mark an answer. With this, we come to the last section of the problem. So let's say a generic form of a linear equation is typically a1x plus b1y plus c1 equal to 0. Or we can write this as a1x plus b1y equal to c1 and a2x plus b2y equal to c2. So all of the equation we have seen in the past, we have a coefficient with x and y, and then there is a constant, and similarly the other two equations. So this is the generic form of any linear equation. Now there is a concept of consistency. What is consistency? The consistency says it is possible to solve the equation. So it may have may have one or more than one values, whereas inconsistency says not possible to solve. There is no value possible. So if you see what is a linear equation in a geometrical format, a linear equation is a straight line. So what is the solution of two linear equations? It's the intersection of these two lines. So basically that one value that satisfies both the equation or both the lines, which is common in both the lines. So that's what we understand by a solution. Now, two lines can be intersecting at one place. So that way we can say these two lines have one solution. Those two lines can be overlapping with each other. So this is a line, and then this is another line. Sorry, none of them are looking overlapping. So these two lines overlapping with each other. So in that case, there may be infinite number of solutions possible, but still solutions are possible. Two lines also can be parallel. So in that case, they will never intersect, and then there is no solution possible. So inconsistency is basically two parallel lines. Consistency can be two lines intersecting at one point, or consistency can be two lines parallel, two lines overlapping with each other. So this is the meaning of consistency. This is the meaning of inconsistency. So what is the condition for inconsistency? The only condition for inconsistency is A1 by A2 should be equal to B1 by B2, but not to be equal to C1 by C2, right? This is the only when the two lines will be parallel, and then there is no solution possible. So this is no solution possible or inconsistent equations. For consistency, there are two scenarios. I'll quickly cover that. So A1 by A2 not equal to B1 by B2 not equal to C1 by C2. If this is the case, then it satisfies two equation has one single solution, right? Sometime, so this is one scenario. The other scenario is A1 by A2 equal to B1 by B2 equal to C1 by C2. If this is the case, then it follows the overlapping scenario. So that means they have infinite number of solutions. So just to summarize this finally, if you have A1 by A2 equal to B1 by B2 equal to C1 by C2, that means you have infinite solution. If you have A1 by A2 not equal to B1 by B2 and not equal to C1 by C2, you have a unique solution. And if you have A1 by A2 equal to B1 by B2 but not equal to C1 by C2, then you have no solution. Both of these are called consistent. This is inconsistent. So that means no solution possible. So that's about it. This is a very, very important area. You need to understand this very well. We'll solve a lot of problem based on this in the subsequent two sessions. And we will further take examples on when it is inconsistent, when it is consistent, what value of a variable can make it consistent, what value of a variable can make it inconsistent. With all that type of problem we'll solve in the coming two sessions, but this is the fundamentals. So what we understood, quickly recap. We first, just let me go back. Yeah. So we first understand what is the difference between equation and expression. And then we typically understand what is a linear equation, what is a quadratic equation, and we focused on linear equation. Then we typically understand how to solve a linear equation, when it is possible to have a unique solution, when it's possible to have more than one solution, two equation, two variable kind of a thing. then we understand always that two equation, two variable may not be always gives you a solution. It has to be an independent equation. Then we went ahead and solve how to solve two equation, two variable kind of a scenario. Then we take three equation, three variable, and show you how to solve for three equation, three variable by taking two equation at a time, eliminate one variable, and take another two equation, eliminate the same variable. That way you can form two equation with two variable, and that's how we can solve. So that's we did. And then we went ahead and see it is possible that you have two equation with three variable. You may not get individual values of each variable, but you will still be able to find out one variable when the ratio of the other two variables are same. It is also possible to find a set of expression when two equation, three variables are there. Say you can find a particular combination of values, but not the individual values that we have seen. We have also seen that three equation, three variable, you need to keep in mind that not always all of them are independent. It is possible when you take two equation, eliminate one variable, form one equation, and take another two equation, eliminate the same variable, form the another two equation with two variable. Both of these equation with two variables only can become dependent. So that way it may not be possible. Here it is possible, but it may not be always possible. So you have to be cautious when there is a data sufficiency kind of a problem, or no solution, or none of this kind of a problem option there in the question. You have to basically solve all the entire equation and actually find out the variable to say that it is possible. Don't just see three equation, three variable, two equation, two variable, and always confirm that it is always possible. Then finally, we went to the last and most important part of consistency and inconsistency. What are the equation in a geometrical sense means, and how that can be used to figure out when the equation is consistent, when the equation has one equation solution, multiple solution, when the equation is inconsistent, or there is no solution possible. So this is a very important chart. Just remember this. Most of the problem in linear equation comes from either this understanding, or given a problem statement, you have to form an equation and solve the problem. With this, we can close today's session. Hope it is helpful. If there is any doubt, please feel free to drop a comment, or you can mail me in the mail ID given in the description box. If you like this video, please like, share, subscribe for the algorithm and for my motivation to create more videos, which is beneficial for you. With this, I'm closing this. See you in the next session, where we will try to cover the concept problems from this topic. Thank you. Have a good day, good night, bye.